Okay, here's warm-up number 21. So I've got two binomials here. I'm going to multiply together. I'm going to FOIL them just like I would with any two binomials. So let's see. First, outer, inner, last. So first will be the 3 and the 2. 3 times 2 is 6. Outer is going to be negative 9i. Inner is going to be 8i. And last will be, let's see, 4i times negative 3i would give me negative 12i squared. Just treating the i's like any variable, like as if they were x's for now, okay? I'm going to start combining like terms. So, let's see. I've got these in the middle. Okay, but there's actually a little bit more simplification I can do. You got to remember what I means. I is the square root of negative 1. So if I squared both sides of this equation, the square root of negative 1 squared would just be negative 1. So I squared equals, this is equal to negative 1. Okay, so this term over here, I've got negative 12 times negative 1. So negative 12 times negative 1 would be positive 12, okay? And then I have more terms that I can combine. So 6 plus 12 would give me 18. You could write negative I plus 18, but typically we're going to, with a complex number like this, we'll put the real part in front and the imaginary part in the back. Okay, so I got 18 minus I. Okay, so next up, I've got this inequality. It's a quadratic inequality. So I'm going to start kind of thinking, well, what would this look like if it were an equation? It would be a parabola that opens upwards because my x squared term is positive, okay? So I'm going to start thinking about, well, how would I just graph that parabola to begin with? Well, there's a number of ways you could do it. I would do it using the axis of symmetry because once I have the axis of symmetry, I can find the vertex. I definitely need the vertex. So the axis of symmetry formula, remember, is negative b over 2a. So my b here would be 4, and my a would be 2. So I got negative 4 over 4. So my axis of symmetry is the line x equals negative 1. Okay? So that means this is going to be the middle of my parabola right here. My vertex has to be somewhere on that. So all I need to do is find the y-coordinate that goes with an x-coordinate of negative 1. In other words, I already know that the x-coordinate's negative 1, so I just plug in a negative 1 for x and pretending that it's an equation for now just to solve this. So let's see. Oops, made a mess of that. Oh well. Okay, so plugging in negative 1 into this. Okay, so let's see. I've got 2 times 1 minus 4 plus 3. So I've got 2 minus 4 is negative 2 plus 3 would be positive 1. So negative 1, 1 is going to be the vertex. So let's put that in the picture, okay? Now what I would do to get a second point, I need at least one more point to get the width of the parabola. And I'm just going to, my y-intercept is going to be 3. You can just plug in zeros for the x's, right, to get the y-intercept. But then those first two terms will just drop out, so I'll have nothing left but y equals 3. So there's my y-intercept, and I can reflect that over the axis of symmetry would be right in the middle, so I can reflect it like that. And now I've got a pretty good idea what this is going to look like. It's tempting to just draw in the parabola, but heads up, since this means this is going to be dashed. Okay, so I'm going to draw in a dashed parabola that goes through those points. Okay, and the other thing I need to do is shade. I need a shade either above the vertex or below the vertex, one side or the other of the parabola. Okay, number of ways you can do this. You can do it with a test point. You can test out 0, 0, see if it comes true or false. If it's true in the inequality, then I would shade the true side. Okay, but what I like to do, since this says y is greater than, if you have the y on the left-hand side of the inequality, if it says greater than, you're just going to shade above. And if it says less than, you shade below. So this one I'm shading above. So that puts me above the vertex, which is inside the parabola. So any point in there should satisfy the inequality. Any point outside should not satisfy it. Like 0, 0, I can do in my head for a second. If I put 0, 0 in, I'd get 0 is greater than 3, and that's false, right? So this would be the side that doesn't work, so I don't shade that side. It's another method, okay? All right, next up, number 3 is a little different because there's no y here, so I'm not going to graph this on an xy plane, on a coordinate plane, because there's no y. I'm actually going to graph this on a number line ultimately. So first thing I'm going to do is solve the related equation. So I'm going to add 1 to both sides. Okay, and I'm just going to change that into an equal for now, because I'm going to solve this for x, and that's going to give me some dividing points where I can divide my number line into different parts. Okay, and so I'll factor this. I'll use a diamond problem up here, taking the 2 and the -3. So I'm looking for two numbers that add to 2, same two numbers multiply to -3. Well, if I've got a -1 and a +3, that's my winning combo, so this is going to factor into x minus 1 times x plus 3. Okay, and then I use the zero product property, so if x minus 1 equals 0, that means x equals 1, and if x plus 3 equals 0, then x equals -3. So those are my dividing points. That's the solution to this equation. It's not the solution to the inequality, but it's a big piece of the solution to the inequality. Okay, so now what I'm going to do, I'm going to draw a number line, and I'm going to put these 2 points on there. -3 would be to the left of +1 on a number line, right? Since this is not underlined, I'm going to put open dots above these 2 dividing points. Okay? And then I need to check. Usually it's going to be connected in the middle. It's going to be all the points in between, or sometimes it'll be the points like this. It'll usually alternate with the solution parts and the non-solution parts. So let's do a little test here. I'm going to test out some different numbers. So I'm going to test one number from each region. I'm going to start with 0, which would be somewhere in here. I'm not worrying about graphing it too accurately. But let's plug 0 into the original inequality and see what happens. Okay, the first 2 terms drop out. I got -4 is greater than -1. Well, no, it isn't. -4 is actually less than -1. This is false. So that means this region in the middle is going to be a false region. So I'm guessing that the other 2 parts are going to be true, and I'm going to get arrows going outwards. But just to double check, let's test -4. Okay, so I'll plug -4 into the original inequality. Okay, and then I've got 16 minus 8 minus 4 is greater than -1. So let's see, 16 minus 12, that would give me 4 is greater than -1. That is true, right? So, hey, this is a true region, like I guessed before. Sorry, I don't know why I put the F way up there. So I got true region and a false region. I'm guessing this is going to be true over here. Let's try another place on the number line. I'm going to try +2. Running out of space, I'll write small here. Again, plugging into the original inequality and just seeing if I get a true or false statement once I clean it up. Sorry, that's so small. So I've got 4 plus 4 minus 4. That would put me at 4 is greater than -1. And that's true again, right? That's actually the same thing I had over here. So this is a true region. So that means any number in those 2 regions should work, but in between will not work. And you could write this as another inequality. But I like to just put my solutions as a number line. Okay. And then the last problem, we've got a rectangular garden plot that measures 3 by 11 feet. Okay, so I'm going to draw a little picture here to start to organize this. I'm going to put the 3 and the 11 inside because I'm going to put a walkway around this rectangular garden. So a walkway of uniform width. Okay, that's the key. This is uniform width. The walkway is the same width all the way around the garden. So let's say the width here is x. Well, the width here would be x, and the width here would be x, and at all the corners, the width is always going to be x. Okay? All right. So it says the rectangle containing the garden and the walkway, so the whole bigger rectangle, has an area of 105 square feet. Okay? All right, so let's keep that in mind. Big rectangle is 105 square feet. Okay? Find the width of the walkway. Hey, so the width is what I marked as x here. All right, so let's think of the width of the big triangle. Well, I've got this piece that's 11 right here, and then that's an x over there and another x. So if I add this all up, I've got x plus 11. That is going to be 2x plus 11 all the way across. Okay, and if I'm going up the side, I've got x, 3, and x. So this is going to be 2x plus 3 in the same kind of way. Okay, so I knew that the area of this big rectangle is 105, so I can do width times height, right? So 2x plus 11 times the quantity 2x plus 3 is going to equal 105. That's the area of the big rectangle, okay? So now I've got an equation. I should be able to solve this for x now. So I'm going to start by foiling. 2x times 2x is 4x squared. 2x times 3 for outer is 6x. Inner, 11 times 2x is 22x. And last, 11 times 3 is 33. Okay, next thing, I'm going to set this equal to 0 by subtracting 105 from both sides. Okay. Oh, I'm also going to combine the 6x and the 22x. All right. So 33 minus 105 is negative 72. Okay. Now I could start to try to factor this. I am going to factor it, but I'm noticing there's a common factor. 4 goes into everything. So you can factor out the 4. Since this is an equation, you could just divide the whole equation by 4. Because factoring out the 4, yeah, 4 would be a factor, but it's not going to lead you to an x value because 4 doesn't equal 0, right? So I'm dividing everything by 4. Okay, now it's starting to look more manageable, and then I'm going to factor that. You could do this with the diamond problem. Here, maybe I'll do that down here. Okay, looking for two numbers that add to 7 and multiply to negative 18. So that's going to be negative 2 and positive 9 will work, right? That's my winning combo here. So this factors into x minus 2 times x plus 9. And then zero product property. Okay, so hey, I've got two possible values for x. 2 and negative 9, but that sidewalk can't be negative 9 feet wide. That doesn't make sense. Negative distance can't exist. So my answer is going to be 2, and I need my my units there. It's 2 feet wide, right? Because the area was in square feet. And there we go. And that's the end of the warm-up, and I'll see you next time.